Hello students, in this video we will study chapter number 1, number system. Before starting this chapter, let us try to recall some of the previous knowledge which we have studied in our previous classes. So first of all, let us try to remember what are natural numbers. So natural numbers are counting numbers which start from 1 and it goes up to infinity. So numbers 1, 2, 3 which goes up to infinity are called natural numbers. The collections of natural numbers are denoted by the letter M. Next, whole numbers. What are whole numbers? If we add 0 to the collection of natural numbers, we will get whole numbers. So numbers 0, 1, 2, 3 are whole numbers. The collection of this number is denoted by the letter W. Next, we will study integers. The collections of number integers is denoted by Z. So if we add negative numbers to the collection of whole numbers, we will get integers. So numbers like -3, -2, -1, 0, 1, 2, 3, are integers. Next is our rational number. So a number is called a rational number if it can be written in the form P by Q, where P and Q are integers and Q not equal to 0. For example, 1 by 2 is a rational number because here the number is in the form P by Q and Q, which is the denominator, is not equal to 0. The number 5 is a rational number because 5 can be written in the form 5 by 1, which is in the form of P by Q, and here also the Q is not equal to 0. So rational number is a collection of natural numbers, whole numbers, and integers. Next, our topic is irrational numbers. So a number is called an irrational number if it cannot be written in the form P by Q, where P and Q are integers and Q not equal to 0. Some of the examples of irrational numbers are √2, √3, √5, etc. Such numbers cannot be written in the form P by Q, so they are all irrational numbers. Next, our topic is real numbers. Collections of real numbers is denoted by the letter R. So what make up the real numbers? Rational numbers and irrational numbers together make up the real numbers. Next, our topic is real numbers and their decimal expansion. To better understand this topic, let us find the decimal expansion of 10 by 3, 7 by 8, and 1 by 7. So after the decimal expansion of these numbers, we get 3.333 as the quotient of 10 by 3, and 0.875 is the quotient of 7 by 8, and 0.142857 as the quotient of 1 by 7. So by observing this, we notice that either the remainders become 0 after a certain stage, or the digits after decimal point start repeating themselves again, as in the case of 10 by 3 and 1 by 7. So in the case of 10 by 3, the repeated digit is 3. Here the digit 3 repeats itself again and again after the decimal point. And in the case of the decimal expansion of 1 by 7, the repeated block is 142857. So the number 142857 repeat again and again after the decimal point. So two cases arises. Case number 1, the remainder becomes 0, and case number 2, the remainder never becomes 0. When the remainder becomes 0, we term the decimal expansion of such numbers as terminating. And in case 2, when the remainder never becomes 0, we term the decimal expansion of such numbers as non-terminating recurring decimal expansion. From the above two cases, we can summarize our result as the decimal expansion of a rational number is either terminating or non-terminating recurring. Moreover, a number whose decimal expansion is terminating or non-terminating recurring is rational. So, what about irrational number? For an irrational number, the decimal expansion of an irrational number is non-terminating, non-recurring. Moreover, a number whose decimal expansion is non-terminating, non-recurring is irrational number. For example, in the decimal expansion of root 2, we can see that after the decimal point, the number does not repeat, and also the digits after the decimal point never ends. So, the decimal expansion of an irrational number is non-terminating and non-recurring decimal. Now, let us try to solve some of the questions from exercise 1.1. So, exercise 1.1, question number 1. Is 0 a rational number? Can you write it in the form P by Q, where P and Q are integers and Q not equal to 0? So the answer to the question number 1 is yes, 0 is a rational number. 0 is a rational number because it can be written as 0 by 1, 0 by 2, etc., which is in the form of P by Q, where P and Q are integers and Q not equal to 0. Exercise 1.1, question number 2. Find 6 rational numbers between 3 and 4. So to find 6 rational numbers between 3 and 4, we have to convert 3 and 4 into their equivalent rational numbers. So to convert 3 and 4 into their equivalent rational numbers, we have to multiply both the numerator and denominator of these numbers by 1 more than 6, which is by 7. So 3 can be written as 3 by 1. Now we have to multiply both the numerator and denominator by 1 more than 6 by 7. So 3 by 1 becomes 21 by 7. And same also for the number 4. We can write 4 as 4 by 1. We have to multiply numerator and denominator by 7, which becomes 28 by 7. Now we have to insert 6 numbers between 21 by 7 and 28 by 7. So the required 6 rational are 6 rational numbers are 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7, and 27 by 7. Question number 3. Find 5 rational numbers between 3 by 5 and 4 by 5. Same here also, we have to multiply the numerator and denominator of both the numbers by 1 more than 5, that is by 6. So therefore 3 by 5 can be written as 3 into 6, 5 into 6, which becomes 18 by 30. And the number 4 by 5 can be written as 4 into 6 by 5 into 6, which is 24 by 30. So the equivalent rational number of 3 by 5 is 18 by 30, and the equivalent rational number of 4 by 5 is 24 by 30. So therefore the required 5 rational numbers are 19 by 30, 20 by 30, 21 by 30, 22 by 30, and 23 by 30. Exercise 1.1, question number 4. State whether the following statements are true or false. Give reason for your answer. Roman number 1. Every natural number is a whole number. This statement is true because you can write true because collection of whole number is made up of 0 and the natural number. Roman number 2. Every integer is a whole number. This statement is false because negative integers are not whole numbers. Roman number 3. Every rational number is a whole number. This statement is also false because number like 1 by 2 are not whole number. So number like 1 by 2, 3 by 5 are not whole numbers. So every rational number is a whole number is a false statement. Exercise 1.2, question number 1. State whether the following statements are true or false. Justify your answer. Roman number 1. Every irrational number is a real number. This statement is true because real numbers are made up of rational numbers and irrational numbers. Next, Roman number 2. Every point on the number line is of the form root m, where m is a natural number. This statement is false because no negative number can be the square root of any natural number. Next, question number 1, Roman number 3. Every real number is an irrational number. Statement is false because number like 2 is a real number but is not an irrational number. Next, exercise 1.2, question number 2. Are the square roots of all positive integers irrational? If not, give an example of the square root of a number that is a rational number. Answer to the question number 2 is no. The square root of all positive integers are not irrational. For example, square root of 4 is a rational number. Exercise 1.2, question number 3. Show how root 5 can be represented on the number line. So to represent root 5 on the number line, we have to have an idea about Pythagoras theorem. So Pythagoras theorem says that in a right triangle ABC, the hypotenuse BC square is equal to AB square plus AC square. So if we are going to make BC as root 5, then our AB is equal to 2 and AC is equal to 1. So from this we can get AB square equal to 2 square and AC square equal to 1 square. So our Pythagoras theorem satisfies this condition, which makes up the hypotenuse BC as root 5. So now let us draw a number line. First of all, let us draw a number line. So with a suitable radius using your compass, mark 3 equal markings. 1, 2, 3. You can mark more if you want. So this will represent 0, 1, 2, 3, 4. After that, you have to draw a perpendicular line on the point 0 on the number line. With the same radius which was taken earlier, that is that of 1 unit, we will draw an arc cutting the perpendicular line at point A. Now let us join this point with the point 2 on the number line. So this line will represent our hypotenuse, that is root 5, and this OB will represent 2 units, and this OA will represent 1 unit. So the hypotenuse AB represents root 5. Now what we are going to do is we have to represent this root 5 on the number line. So taking the radius as AB and with center O, will cut an arc, will draw an arc on the number line such that it cuts the number line